and Azure fundamentals. So I have won around 15 hackathons in total in last 3 years, where my solutions have been accepted into industries of national and international scale. And I've been actively speaking and mentoring various sessions in and around India as well as in global scale as well. And I have published around 3 research papers on AI and IoT. We can find it on Springer as well. And I have 1 patent coming up. And off topic, I'm a guitarist and also having a local band here. And also I'm a hardcore metal fan. So today's agenda will be like covering from the basics of machine learning to the deep dive of our Azure automated machine learning. So I want to make sure that everyone here wants to be on the same side of the sea, because we'll be this kind of a new tool. So I will make sure that we'll be starting from the very basic, so that it will be very convenient for every of you here. So let's get started with the topic. So is everything all right? So great. Okay.
Yeah, please go ahead. Yeah, please go ahead. We can hear you fine.
Sure. Okay. So we'll be dealing with I'll be giving a small intro on what is machine learning. So it is a process of all having a mathematical data consisting of probability, linear algebraic, and statistics, and so on, so that we'll be helping a computer to learn a data without giving any direct instruction. So it is always considered as a subset of artificial intelligence. So machine learning is only a subset of it. We can find computer vision and many more such applications of AI under this. And the machine learning uses various algorithms to identify insights, patterns, and other things within the data, so that we'll be creating a data model that will be helping us to predict the required predictions. So I think I have given too much of information within these formal definitions. So let me break it down. So let me ask you, like if I'm asking you to code a simple program, let us say add 2 numbers. So what I'll be giving you is input of 2 numbers, and you'll be performing the program that is the addition of 2 numbers, and you'll be giving me the output data. So that's how the classical programming works. But in machine learning, I'll be giving you the input output pairs. So for example, I'll be giving 1 and 4 as input and the output as 5. And I'll be giving more and more examples such that your machine learning model will be grasping the pattern which is lying within the data, and it will be creating a hypothesis. So that hypothesis may or may not be equal to your actual function you're looking for. So it is a simple addition program. So a model will be trying to figure out an addition program here as well. So what if the data is so complex and you're figuring out a very big hypothesis? So your model will be giving out an approximate function to make sure that it matches with the input and output pairs. So this is how a simple machine learning can be explained in simple words. So there are various types of machine learning, like supervised, unsupervised, and reinforcement learning. So in supervised learning, we'll be having the input and output pairs. So in previous slide, if you see, I have given the input and output pair training pairs to the machine learning model. So that is called supervised learning. So what happens in unsupervised is that we'll be giving out only the input data. For example, I'll be giving out the people's social media presence. So we'll be clustering people based upon their shopping activity and so on. So we will not be having a particular output, but still we'll be trying to gather an insight or group of people or group the data based upon the existing input data alone. So that's called unsupervised learning. And the reinforcement learning is based upon the reward and penalty. So you'll be asked to do, the model will be giving out a prediction. So we'll be evaluating the prediction. If it is right, we'll be giving a reward. If it is not, we'll be giving a penalty. And the machine learning model will keep learning in such a way that it comes out with the approximate hypothesis. So why we need a machine learning? So it uncovers the insights which is very hard to find in a conventional and a manual way. So having a big data and you want to find an insight within that, so it is probably a very difficult task. So machine learning makes it pretty easy, and it enhances the user experience. So if you're in your shopping website and you're ordering something, and next time you go there, we'll be recommending some items which will be interesting you to buy. So that recommendation systems and so and so are all the use cases of machine learning here, and it reduces the risk. And the risk in the sense, there are few applications where even I had presented to one of the bank in India, where it identifies a fraudulent transactions that is taking place within the credits and so on. So it saves a millions and millions of money for that particular organization. So machine learning helps us to keep track of the anomalies as well and anticipate customer behavior, and it also helps our organization to keep that cost in the low. So this is one of the important topic which will be a base for the automated machine learning. So the stages of how we are going to do machine learning can be put into 4 steps. So the first steps involves data collection and pre-processing. So I would say this is one of the important module of any machine learning model. So the first thing is you need to identify a data source which has at least a decent number of examples of the features as well as output. So we need to identify the data sources available for us. And the next thing is we need to able to create a pipeline or create a way to make sure that all the data sources that are available we have identified so far need to be put into one single place. So the data collection techniques can be implemented here. And once the data is collected and to our workplace, so we need to make sure the data is in the right form. To make sure that we say the data is in right form is that we make sure that we remove the anomalies such as missing rows or inconsistent data type and so and so. And as an output, we'll be getting a data which is clean, that is, which is free from all the impurities such as missing data and mismatch of data types and so and so. Once that clean data is collected and stored, we'll be doing the domain understanding, where we'll be collecting the manual insights from the domain experts to make sure we'll be building our right machine learning model. So once this stage is done, we'll be moving out to the train the model stage. So here we'll be like splitting the data into train and test. So if you had noticed that slide in the beginning, there is a thing called test input with the hypothesis that gives out the test output. So here is why the input training pass and the validation data comes into picture. So we'll be splitting the data to validate how well the model predicts in future based upon the hypothesis it creates. And selecting the model is one of the biggest tasks here. So first of all, we need to identify what type of problem we are dealing with. So if it is a classification or regression or something like that. So if it is a classification, we classify whether a particular output is a discrete variable. So let us say if it is a binary, you'll be predicting as 0, 1, or if it is a multi-classification, you'll be predicting into multiple classes and so on. So we need an appropriate model for doing that. And there are multiple already existing models available based upon the statistics and so on. So if you're already working with a machine learning framework such as sklearn, TensorFlow, Keras, I think you'll be very much know about the models to load in and work upon it. And the next one is the training. So once we have the model and the clean data and we have splitted the data, we need to train the model based upon the data we got. So for that, we'll be training the model for a number of iterations. And during the iteration, the model keeps learning. It changes the weight and the biases and so to make sure that the model keeps learning and it is accurate enough to give out a hypothesis that will be able to predict our the validation data. So this training will be going on for a number of limits for the epochs or the iterations you specify. And once the training is done, we'll be again evaluating the model to make sure that the model performs well by hyperparameter tuning. So what means of the hyperparameter tuning is that so a model consists of n number of parameters within itself. So if you take SVM and so it got the value of C, gamma, and so on. So we'll be having multiple the tuning parameters here. So we'll be tuning the parameter to give out the best model we can able to get it. So once we get the model which is fully trained and which is best according to our parameter tuning and so and so, we'll be having the model here. So we need to validate whether the model is good or not. So we'll be validating on the test data set we have split it earlier, and we'll be evaluating the results. So here comes a reversible process where the 2 and 3 goes into iteration. So we'll be, if the model is not good, we'll be again switching the model, doing all the processes again, and we'll be again doing the hyperparameter tuning. Then we'll be again validating on the test data set and so on. So once upon a number of experiments going on and on, we'll be able to come to a final decision where we finalize the model that, okay, this model performs better than other models. So if you're doing with the classification, let's say SVM performs well than random forest or decision tree. So we finalize a particular model here. So once that is done, we'll be predicting the real-time data we get. So based upon the prediction and the model monitoring. So what means the model monitoring is that, so if you have some data you have trained and everything is well and good, so you are deployed in your real-time production. So in one particular point of time, when the data, there might be some variation data which comes there, and your model may not perform as well as it did before. So we need to make sure the model stays consistent and it performs well throughout the data it receives. So to make sure that it does, we'll be keep monitoring the model based upon the metrics such as precision or whatsoever the metrics we need to monitor. And if the metrics falls below a particular threshold, we'll be like again reiterating the model based upon the data and so on. So, and this comes only on the production data. So, and visualization as usual will be like visualizing the data based upon the output and so on. So this 4 stages is one of the crucial thing we are going to discuss, and will be a very big base and platform for Azure automated machine learning. So if you're well and good, if you have understood how the process goes on, this will be easier for me to take to the further session here. So now comes a thing, what is automated machine learning, or in short, we call it AutoML. So AutoML is a process of automating all the tasks of machine learning we have discussed before. So it involves all the collection, pre-processing, and training of data, validating, and so on. So we'll be able to give out a best model we can get from as an output of AutoML. So why we need AutoML, where we can do the experiment by ourselves. So it will be very much better if we have some automated tasks, right? And what if suppose I'm a data scientist and if I'm very much good at coding, so I'll probably take a data set, work upon myself. So if there are many instances where the people who do not have the programming or the data knowledge have a particular requirement or a particular need to come to use machine learning or its data science for their need of research papers or whatsoever so far. So this AutoML will give out, will be using us as an interface for them to able to create the model without having any knowledge about the data science or the data or the machine learning or whatsoever. So actually, it is a very big boon which is enabling every developer and non-developer to come up with the machine learning techniques. So input into simple words, so data scientists will be having a particular framework to work on, a particular languages, and he'll be creating his own workflow and so on, so to create his machine learning model and so on. And what if non-pro data scientists will be using a drag and drop or a select kind of a user interface where he'll be doing the exact job of the data scientist, but without having the knowledge of data science, where this AutoML will be giving out every insight we needed to make sure the non-data scientists need to know. So this is what the AutoML refers to. So what happens is this GIF almost summarizes the entire process. So it does the feature selection. So it comes under the data processing, and there are multiple models we need to select for the AutoML. So as I told earlier, so we can experiment the thing with SVM, random forest, and so on. So there are multiple data classification models available. So this AutoML itself sanitizes the data, and it selects the features which is only required to for the prediction, and it also helps us to select the model which makes the best prediction, and it also does the hyperparameter tuning and gives out the prediction. Wow, this is a one of the biggest boon one can get. Like as a data scientist, it is like completely taking my burden off. So automating the end process is something very useful for us. So this GIF almost summarizes the entire process here. Though there comes a hyperparameter tuning and we get the optimized model here. So why do we need to have AutoML, and where do we need conventional ML practices? So if we automate a task, and that will really put out the person who is actually doing the job. So for example, if you are automating some work, there were in earlier times there were like hundreds of accountants in a company doing that same work. So after the computers and improvement in technology, that reduced, right? So but still it doesn't completely eradicate the role of accountant, but still we need accountant at any time. So that same scenario applies here. So AutoML will be helping us to simplify the process and assisting us to give a better results, but it won't actually replace a data scientist in real life. So that is what really I want to mention here. So, and I'll be like giving out a scenario where why we need AutoML and where do we not need an AutoML. So that is what an important one, because we need to be make sure that where we need to use one and where we need not use the AutoML. So the best thing about the AutoML, as we discussed before, is that we do not need to have any programming knowledge. So if you are a data science non-programmer or a researcher who doesn't have a programming background, you are the most welcome to use AutoML to leverage the power of machine learning, and it saves time and resources. So in the earlier discussion, we told that we'll be selecting many models, we'll be doing the hyperparameter tuning, and we'll be again doing the process of training and validation again and again till we get a finalized model. So the AutoML actually automates a task, but it does in a way it saves us time and resources. So and also it leverages the best practices for data science. So the best practices in the sense we need to visualize how each and every model performs for a particular data. We need to like have an insight about how everything works, and it must be explainable such that whatever results we are coming up, we need to be having a proof of concept or a justification content to make sure that this model is performing well, and this is a reason for that. So actually we have explainable AI here as well, which helps us to give out the insights why we have selected the model and why we have been using that, and so and so. And it provides agile problem solving. So in agile methodology is followed in organizations, so it involves a lot of changes and by the team leader or the client. So with the changes, we need to have more experiments with the data and more experiments with the model. So since it gives us the power to experiment with a lot of data insights and the model and the machine learning model and so on, so it provides us the agile problem solving. And this is when do we need to use AutoML? So as we discussed before, any non-programmer is welcome to use AutoML. And I think this one of the justification I personally used to give to others is that when you're handling a too complex data, imagine like you're usually you will be having a data set and you'll have some insights about the data. So you'll be like knowing what features, what does a feature mean, and what values does it contain, what will be the range of the values, and how well the feature is important for our prediction, and so on. So imagine you're having a complex data and you do not have a domain knowledge to explain why this data is here and how important the data is. So if a situation like that comes, I think the best bet is to use an AutoML, and usually that works very well, because so since if you are handling a too complex data, it is very difficult to bring up a machine learning model that will be able to give out a very good prediction. So AutoML always gives out the decent and the best prediction we can get. And quick implementation. Yeah, we have saved the time and resources, so the implementation will be very quick. And if imagine you have come up with the stage of having your own custom model, but your model has a n number of parameters to fine tune. So for example, for SVM we have around 3 to 4 or so and so. So imagine if you're having a model which has hundreds of parameters, and each parameter has a range of values, and if you need to fine tune that model, then it is a very difficult task. So at that time, it's best if we go to AutoML. So since now that till now we have come up with the thing, we have discussed about what is machine learning and what are the techniques used in machine learning. We have covered the basics of that, and we also covered what is AutoML and how the AutoML is simplifying the process of the machine learning techniques. And now we will come into the main section of our the talk today, and that is the Azure automated machine learning. So what does Azure has that we can use for our convenience? So in AutoML, so we'll be having a number of pipelines in parallel, and each pipeline will be carrying out its own algorithm, and will be fine tuning its own the parameters for that particular algorithm, and so on. So since it uses a number of pipelines in parallel, it will be like it saves us the time and resources. Imagine if you're having a one core and you're having a local computer and you're executing this thing. I think that that will be a very tedious task, and maybe your system won't support such kind of a big operation. But when it comes to that, we are leveraging the power of Azure cloud, and which gives out the resources we need to carry out our compute purposes. So we'll be creating out the number of pipelines in parallel, and this algorithms will be like paired with the feature selection. So in the initial previous slides, we have discussed how the feature selection works. So let me give it again. So feature selection is a process where we select the features which contributes well to the final output. So here that takes only if we have some domain knowledge, we'll be able to do that. So here AutoML it creates out the statistical inferences between the features and the output, and it selects the required output for us. You can also do it manually, but it also does it automates as well. And based upon all the models which have been trained so far, and the feature selection and the hyperparameter tuning, it gives us the best model it has trained so far, which is considered to be the best one here. So I think we can keep if we keep running the machine learning model for better outcome, we can keep doing that. But still, we need a exit criteria to make sure that the experiment stops at this particular time, or this particular criteria meets. So we'll be setting up exit criteria. So it will be maybe the hours of training, or the number of patients, and so on. And this is a features which are given by Azure AutoML. So we can do three types of problems here. One is regression, where we be predicting a numerical value, and classification is we'll be able to classify into multi-class. And another one is time series forecast. So time series forecast is where we'll be predicting out the future trends and so on, so based upon the existing time series. So best example I would give is a stock exchange, where we can, based upon the current trends, will be able to predict the opening and closing rates of the products for the future as well. So this is one of the time series forecasting. It also supports time series forecasting, and it is transparent. What I mean by transparent is that, as we discussed earlier, it gives out an explain a justification for your content, as well as the visualization to make sure that your model works well only because of these reasons. So if you're able to justify something, so that is authentic to be able to present to anyone. And it is open and interoperable, in the sense it is highly we can integrate it with any framework, most of the frameworks, and it supports most of the machine learning frameworks as well. and it is enterprise grade, so we can also deploy into production. I will soon show you how to do that in the next following thing. So once, as we discussed earlier, how will be like what is the process of machine learning, then we discussed how those processes are simplified and automated by AutoML. And here, using the Azure AutoML, what are the steps we need to do to make to leverage this power? So first thing is we need to identify the type of problem we are dealing with and the platform. So as I told already, so we have three types of problems supported as of now. One is regression, classification, and time series forecasting. Can do any one of the three. And the platform, so it gives us as a choice of two here. So one is Azure ML Studio, where there is only limited code we need to do, and most of them are taken care by UI thing. So I'll be only discussing about the ML Studio here. And the next one is Python SDK, where if you are interested in programming, but you also need to you are interested in leveraging the power of AutoML, I think Python SDK would be a better choice. And if you are a non-programmer or a researcher and you have need to do the AutoML, then ML Studio is a preferred one here. So the next thing is the data and the compute source. So in Azure entire workspace, for anything to run or anything to be computed, we need a compute instance as a backend. So for the compute instance, we can either use our local computer as a compute instance, or we can spin up a VM, or we can use Azure Databricks and so on. And for the data source, it can be either NumPy arrays or Pandas data frames. So as of now, in our future, in our upcoming hands-on session, I'll be only discussing about the tabular data, and one of the typical problems we usually do with AutoML. So once these are the first two steps, and the third thing is to config the AutoML parameters. Now you might have a question. What is that? You have explained that the AutoML takes care of all the hyperparameter tuning and so on, and everything. So why do I need to config the parameters again here? So now this parameters is what will be configured for AutoML. So what are the parameters we'll be dealing here is that the iterations over different models. So there are n number of models we can experiment with, but if you have a personal preference, or if you feel that these are the algorithms I do not wish to experiment upon, you can, that's your opinion. So the AutoML also gives us does not take the entire process automatically, but it also gives a manual override for us to make sure that we are in the deciding factor for few things. So we can decide whatever models we need to consider for our AutoML, and what are the settings we need to have for hyperparameter tuning and the advanced featureization. So you can also, if you have some data, you can also go and remove few data columns, or you can perform some feature engineering techniques and so on. And you can also set the metric upon which your model should be evaluated. So if it is a regression, obviously you'll be going with the value of root mean squared value, and if it is a classification, we'll be usually going with F1 score or the AUC weighted and so on. So these are the typical metrics we usually evaluate a particular type of machine learning model. And once these are done, we will be submitting the experiment in the workspace, and this will be like, as discussed earlier, will be like training in parallel pipelines, and finally it will be giving out the best model we need to have for the data we are having here. So these are the steps we need to do for our Azure AutoML. So as discussed earlier, so AutoML supports feature engineering. As I told, you can select few columns to be needed to be added, or we can remove few features to be removed, and so on. So why do we need to do that? Is that a data can be either overfitting or imbalanced, or in some time cases. So what do I mean by imbalanced data? So imagine you are a machine learning model, and I'm asking you to classify. You don't know anything. So I'm giving out the pictures of a bus and a car. So I'll be asking you to, like, I'm training you with the pictures of buses and cars. So I'm giving out 100 pictures of bus, but I'm only giving you 10 pictures of car. So then I'm taking you outside to a highway or a freeway there, and I'm asking you to point out which one is a bus and which one is a car. And obviously you'll be making a big mistake when it comes to car, because you haven't much trained upon the particular data. So to make sure that the data is balanced, we need to have an equal number of cases for everything. So at that time, feature engineering comes into play. So we'll be using various techniques such as sampling and so on, so to make sure that each and every class has an equal number of data here. And obviously you'll be like doing the feature normalization, missing data. You can also specify what type of data type your column should hold, and if the column does not isn't consistent with the type of data you assign, so what need to be done, you can also specify it on your own. So that those are the feature engineering techniques which are given out by Azure AutoML. And there is one of the best thing about Azure AutoML is that you can also specify your own feature engineering technique. So about discussed are all like UI kind of stuff, but there is a provision for us to also include our own feature engineering technique in this process as well. And next comes the ensemble models. So little this might be little confusing for the beginners, but I'll make sure I'll put it into simple words here. So as I told earlier, we'll be as a result of an AutoML, you'll be able to select best the model we need to have for our classifier for our data, right? So what if we have a n number of data, we'll be selecting out the best one. In models, we'll be like giving out the input to n classifiers, and we'll be like selecting the classifier which gives the best one out of all the n things. So we do not have one particular model for the prediction, but it has like around three things to three or for two or more classifiers to make sure that it gives out the best one. So let me put that into simple words. So let me take a simple example. So I need some assistant, and I have two assistants with me doing an experiment. So what do I do is that instead of selecting a best assistant with myself, and if I have some doubt with the physics experiment, I need not be asking that doubt only to the best one, but instead I'll be asking to both of them, and I'll be selecting which one gives out the best answer. So this will be having a leverage of getting the best results out of the best. So ensemble models always usually performs better than the conventional one single model, because a type of data might perform well for a single classifier, but might not perform for other things. So for example, if input n performs well for SVM, but it does not perform for decision tree, and in other data type of row, it performs well for decision tree but not for SVM. So to make sure that this eradicates this kind of problems, you'll be like having both the SVM and decision tree. We'll be like picking out which one gives the best answer for both of that. So there are a few techniques we need to like to pick out the best thing. So that will be basing on the simple voting, weighted confidence, and so on. So with this, so much of input I have given you so far, I think if I jump into hands-on session, I think you'll be having a clear view of whatever we have discussed so far. So I will start with the very basics here. So I'll just log in into my Azure. Just a second. So what you have to do is that for anything in Azure, we need to create a resource. So first I'll be creating a resource. So since we are doing a machine learning task here, so I'll be selecting a machine learning. And you need to create a workspace. So the workspace is where all the assets related to a particular machine learning thing, we will be working out everything in a workspace, and the workspace is enclosed within a resource group. So the resource group shares the assets needed to be performed for the workspace. So you give out you can select the existing, I have already created a resource group. You can create a new one or the select one if you already have, and give the name for your workspace and region. And the important thing is you need to select the enterprise. So why we need to have enterprise workspace Workspace edition is that only that supposed the ML Studio Enterprise Workspace edition supports Enterprise Studio and Basic does not support. So please make sure that you select Enterprise and you review and create a one. So since I have already created, I'll just show you the resource I have already created here. So coming to the resource groups, I've already created a resource group where inside which I have a workspace. So now what you have to do is that I have a workspace named docs.ws. Yes. So this is my workspace I had created and this is my resource group. So now what you have to do is you need to go to ml.azure.com. So this is where the Azure ML Studio, it helps us to do the task perfectly. So once that is done, you need to select the default directory. I'm using a free subscription here, and if you have a subscription of your own, that's well and good. And the workspace, you need to select the workspace you had created in the earlier stage. So you need to select this workspace and you need to select get started. So this will load our workspace here. So yeah. So the next thing you need to do is that you need to create an auto ML run. So what you have to do is go to this automated ML. Already I have created few runs. Don't worry, you can start from the beginning. So what you have to do is you need to create a new auto ML automated run. And now we need to import a particular data set. So we will be dealing with particular data here. We'll be importing from my local files. Give out a name as you wish. For example, this is my Vivek data set. And you need to select the type of data we are dealing with is actually a tabular data. So select it as a tabular and version is 1. You can give out the description if you want, it's optional. And as we can see here, there is actually a storage account created along with the resource. So we are actually using the same the blob storage for our storing our data. So you need not worry about what is that if you are new to the storage kind of thing. So already there is an existing storage where we can store our data set. So select currently selected data store and so on. So we can browse the files you needed for your data set. So I'm going to browse here. So downloads, and this is a bank marketing training data set. So I'm here, I'm importing it and everything looks fine. I'm going to do the next step. It's uploading and cool. It takes a few, yeah, fine. If you have only around 4 MB of data set, so it's uploaded very quickly. And it has parsed the entire data sets and so on. So, oh God. I think there might be some few issues, but no worries. I have already done the entire process to make sure that I have prepared for this scenario as well. So don't worry. So what I have to do is that I'll come again here. So already I had, what you have to do is that you need to create your own data set as you need to follow that steps and you need to create a new one. So once that is done, you need to create an experiment for that. So in that experiment, I will be creating my first AutoML experiment. So these are the things we already done. So I'll be again selecting and showing how it's done. So I have uploaded the data set and it's here right now. So next one is I need to configure the run. So for the configure thing run, as I told you earlier, we need some compute instance for anything in the Azure to run. So you need to create, you can select the existing experiment. I have selected them, and your target column in the data set is Y actually. So it predicts whether we need to give out the marketing and so on. So I've already created a compute instance. If not, create a new compute instance and you're good to go. And I'll just show you how it works. So create a new compute name, and for the minimum nodes, give it. And for advanced settings, you need not worry about that. And for visual mission size, you can select one which is suitable for you. So since I have a free subscription, I'm only available to spin up one thing. So once that is done, you'll be creating your own experiment here. And so once this is done, we'll be creating out, running out the experiment here. So what does this experiment does is that it carries out various number of algorithms, and it finally, once that the entire process completes, it actually takes around a few hours based upon the exit criteria you had given. So for the exit criteria, you can specify it as the training for 1 hour and so on. So once that is done, we can select the best model. The automation will be giving out the best model summary. So here the algorithm of max ABS scalar of the max ABS scalar is one of the normalization feature engineering technique, and the light GBM is a model which gives out the best output for the current experiment run. So actually, it had these are the metrics it had given out. So F1 score is 0.09, so which is very good. And these are the model it had evaluated with. So it takes a few seconds to load. So this is it has 100% sampling and so on. So actually it gives out the explanation. So there are we can use the visualizations here and the metrics. So we can the confusion matrix we need to know about. So what is a true positive, what is a true negative, and false positive and false negative, and we can have the accuracy table here. We can generate a number of charts based upon everything. So this is the ROC curve we have here, so which is an amazing curve here. If you have little knowledge about how the ROC works, so this shows that it has a very good model we have deployed so far. So once these are all done, we have so far what we have done is that we have imported the data set, and we started an experiment, and we have imported a compute. We have instantiated a compute instance, and we have started the experiment run. So once that is done, we'll be able to get the experiment run here. What is the number of experiment dozen? So I have only stopped it for 10 seconds, so 10 minutes. It had evaluated around n number of models, and it gave out the best thing. So for time constraint, I have stopped for 10 minutes so far. So we'll be able to get out the relevant metrics, charts, and so on. So whatever models it had, these are the models it had evaluated against. So upon which this gave us the best model. So you can see it is evaluated against these things, and these are the metrics we have got, and these are the runs. So the runs are the one which I have told earlier, which are the parallel pipelines for each and every model. So yes, so max ABS scalar is a feature engineering technique, and the light GBM is the model we have chosen. So the first thing is a featureization technique, and second was a machine learning model. And this is a thing we have got. So once we have got the best model, we can deploy it with just one click of button. So for deploy, you can create it. Okay, this is my Vivek AutoML model. Sorry for the typo. And description if you want to give. So what is the compute instance? It depends upon either you can select for Kubernetes or for container instances. So I would prefer ACI because it is very low in cost as compared to Kubernetes services. You can go with either one. It doesn't matter. And if you click deploy, and it will be deployed in few seconds. You can also view the deployment in the source groups as well. So if you have seen, this is my the one which I have deployed earlier, which are the container instances. So now which I'm going to deploy will be also shown here. So success Vivek AutoML models as deployment has started successfully. It actually takes a few minutes, couple of minutes to do that. So let's not wait for that. So once that is done, we'll be able to see the deployment in one of our instances here. So we can do a number of things here, and this is the work tutorial which I had followed. So for the learning resources, I have attached the needed ones here. So I have written if you're new to machine learning, I have written a article on Medium which covers all the basic stuff. And this is the second one, shows us the Microsoft documentation, which explains the machine learning in very basic layman terms. And you can create a free Azure account in the following link here. And for AutoML machine learning, which I had discussed so far, is found in the last link here. So right now I'm open for Q&A. I think we have around 10 minutes of time
yes.
here.
Your timing is perfect, Vivek. We're at 10:49. We've got 10 minutes left, and we would love to hear from the audience and attendees. Any questions, thoughts, feedback? Please feel free to jump in and ask questions or post them on the meeting chat. Thank you, Prashant. He said thanks for an excellent session on AutoML.
Thank you, Prashant.
And we've got 39 people, so hopefully feel free to, we've got a question from Gustav. Thank you so much for your question. He asks you, Vivek, can you talk about interpretation?
Yeah, a good question. Actually, I had skipped that part. I didn't cover that much part in the demo, but still, let me give us just a second. So, interpretation. If you're going with an AutoML and it gives out results that this model works better and this is the data, you need to believe me. So, but you need an authentic proof that, okay, this is a reason why your model performed very well as compared to others. So for that, we can go with the explainable thing. So as we have seen here, so just a second, I will show you where we need to find that. So it shows explanations and preview. So it has no explanation to give here, but if you have if you're running for the entire experiment, it will sure give you out a full meaningful insight here. So actually, it takes around around a hour, because I have set a limit for 1 hour of training. So once that is completely done, you'll be able to give explanations here. I'm not sure that it is because of free subscription we have done here, but I think once a full experiment run is done, we'll be able to get out the explanations. And if we need to have an explanation for the particular model, as I told earlier, you can go for the metrics, and we can also generate the charts such as confusion matrix, ROC curve, and so on and so forth. So I think that would help you to give out the interpretation. I think that would have answered your question, Gustav.
I hope so, Gustav. Feel free to post a thumbs up if that answered your question. And we have 4 minutes for another question. Anybody have an additional question? Oh, Gustav said yes. Anthony has a question. Are the explanation in plain speak for non-data science professional? Oh, are there explanations in plain speak for non-data science professionals? Thank you, Anthony. That's a great question.
Yeah, good question.
For people like me.
Yeah, so that will be one of the basic doubts everyone gets. So will I be able to understand the explanation it gives? Yes, that's a very big yes, because it gives out the explanation in the form of graphs and visualizations. So, and it gives out the explanation in for example, if you have a chart and it explains what the chart means and what are the parameters the chart includes, for example, x-axis, y-axis, what it means, and whether the model had performed good, and it shows what is the threshold which is needed to make sure that it is a good one. It will give out every insight you need to understand a graph or understand a particular line to make sure that not a non-programmer or a non-data scientist doesn't feel like he's left out in that explanation column. So it makes sure that it gives out explanation in very plain English, and I can also gives out the explanations in the form of graphs and visualizations, and it also gives an explanation for each and every graphs it has provided so far.
Great. And we have one more question to piggyback off Anthony's question. Can you talk about a hypothetical situation or talk about an explanation from the previous experience? And then I will show you guys the link.
So I have worked a particular few problems in AutoML, and what I had experimented with it, it gives out a variation of how well the models perform with each other. So based on the metrics it had performed, I have shown you an ROC curve kind of stuff with for one model, right? So it gives out a complete inference of how well the model has performed with each other, and how much resources it has consumed, and how well the metric, what is the metric we have set, and how well the metric is useful for us to make sure to say that this prediction is one of the best, and how that model has actually justified that this the results it had given has this output. For example, if I'm using an SVM, let us just put into plain words. So I'm using a machine learning model, so it gives out the best results. So it will say I had used this kind of parameters. These are the settings for my parameters, and I have run for these of iterations. And because of these iterations, I had achieved the result of the one I had given. So which is the best one. And it also explains why this parameter matters so far, and it also gives out a comparison between that model and the various others model it has tested with, and so forth. So this is a explanations we can incur from the existing explanations given in the AutoML.
And we have one more question, follow up from Anthony. And by the way, I just posted the URL where you can download all of these presentations. I think they're already up there, right? Is this presentation up there, Vivek?
Yeah, it is uploaded, and you'll be able to get it.
Okay, the follow-up question is, do these explain that this data is important and this one is not very important for determining the result?
Exactly, yeah, it does. So what when we are importing a data set, so this gives us as an option for feature engineering. So there are few situations where I think there are.
We cannot see your screen anymore, but please go ahead.
Okay, there are some situations where the employee ID doesn't matter for your prediction. And what if a column which is irrelevant to your prediction comes up? It usually identifies. So for that, usually is the date, or maybe the ID, or the index values, and so on. So it usually identifies these kind of features which are not relevant, but there might be few features which you will be able to give an insight. So for example, if I'm determining a prediction case in our scenario, so I do not need the day of the week, so I can just eliminate it. So I can do that with the click of a button. But the AutoML actually it featureizes a few columns such as indexes, dates, and so on. So actually it does.
Wonderful.
Anthony,
any other questions? I think that it's just the last comment. Statistics can scare people.
Absolutely, and AutoML has saved our.
Well, we would recommend, yeah, they can go up and everyone can go up and do a free trial on Azure. With in practice some ML and AI with a free trial, right?
Yeah. Azure actually gives you around $200 of free trial for 1 month, so which is a very good one, right? Yeah. So I have used a free Azure trial here. So yeah.
Any additional questions? We have 3 minutes left.
And you can connect with me through LinkedIn, GitHub, and Twitter. So I'm very active in these social media handles. So we can ping me there. I think you'll be able to find out the links for that same in that presentation. You can find the presentation in the session. So you can also mail me at vivekraja98@gmail.com, and you can ping me any questions if you want to collaborate with me. I'm always open. And if you have any doubts or if you have any insights, I'm very much will be happy to assist you in any kind of matter related to machine learning and cloud.
Well, Vivek, I want to thank you so much. That was an outstanding presentation, super helpful, and thank you for the questions, everybody. It's a very productive session. Any last comments before we close this call and stop recording? Okay, thank you, everybody. This concludes our presentation. Have a great day.
Have a great day.
Thank you, Vivek.
Thank you, Nancy. Have a good day.
Hi, Ginger. This is Matt Whitman. I'll be helping out this morning for you.
Hello, Matt. I figure out how to use the unmute button now. Do all right?
All right, 11 o'clock. Shall we get started?
Certainly. I hope I can share my screen okay. That's the only thing that I know has issues with Teams, so assume that all works.
All right. Well, thank you everyone for joining. I have posted on, I'm sharing my screen right now to share with you guys. I'm sure this is a slide that you've seen and you'll continue to see all day long. You can access the slides from today's presentation here, and the YouTube channel will be posting all the recordings there. So with that, I'm going to turn it over to Ginger, and she's going to be talking about sparking Azure Synapse for machine learning.
Thank you very much, Matt. Let me...
Hey, Matt, can you also start recording?
I will do that right now.
Thank you.
Trying to figure out how to share my screen here. Press Control.